Hello there, my darlings. Fancy seeing you here. Welcome to class 10 of Unit 4, Finding Equations of Lines, Part 3, the 3 mix. So, once again, you have a problem set for me to complete tonight. This video is an optional addendum. So if you find yourself needing a little bit more practice, want to see a couple more problems in action, here you go. But this video is not required. You are not obligated to watch video 4.10. However, you're more than welcome to keep me company. I'm lonely. I'll take what I can get. Let's do some practice. So, once again, I'm not going to tell you when to pause the video. My advice to you is to take 2 minutes, 3 minutes, pause, give yourself a little bit of time for each problem, and then come back once you've got some idea of what we're doing. Alrighty. So let's say, for example, I want to find the equation of some vertical and horizontal lines to start. So I've got a vertical line through the point -6, 3. I want to find its equation. Well, I know if I've got a vertical lines, of course, happen when x is alone in the equation. So x is by itself. Because it's vertical, I know it needs to be x equals. So looking at my point, well, my x value here is -6. So the equation of my line must be x equals -6. Same idea with horizontal lines, right? If a line is horizontal, x can be whatever it wants, but the y value must be consistent. If its elevation above the x-axis is the same. So horizontal lines, this tells me it's y by itself. Y is going to be equal to whatever the y value of my point is. Here it's -4. So y equals -4 is the equation of my line. Same idea here, horizontal line through 1, 1. Well, again, horizontal lines happen when y is by itself. I know here I'm passing through the y value of 1, so y equals 1 is my coordinate. And then same thing, vertical line through -8, -7. Vertical lines happen when x is by itself. Here the x coordinate of my point is -8. But I could also kind of up the ante here and ask this in a kind of creative way. Let's say that I have a horizontal line and a vertical line that intersect. They cross each other at the point -3, 7. I want to find their equations. So for example, right, or not for example, right, for the sake of this example, horizontal lines, of course, these happen when y is equal to something. Vertical lines, of course, these happen when x is equal to something. So knowing that my point -3, 7 has an x value of -3 and a y value of +7, my horizontal line would have to be y equals whatever my coordinate is, so y equals 7. And then my vertical line would have to be x equals whatever my x value is, which is -3. So these are the equations of my two lines. Fantastic. Moving on. Let's find some equations of some non-vertical and horizontal lines. So I've got some diagonals here. I want to find the equation of the lines from these graphs. So here, looking at my first one, part A. Again, probably my wisest move here is to count my rise and my run and find some nice points. Notice here it just so happens that I've got a nice point on my y-axis here. For part A, this guy has a coordinate of 1, 2, 3, 4, 0, -5. That tells me that my y-intercept of B, of course, is going to be -5. That's where I am on the y-axis. And then here, if I count some rises and some runs, well, I've got another nice point over here. So I go 1, 2, 3 down for my rise of 3. 1, 2, 3, 4 over for my run of 4. That tells me my slope, I have a rise of 3, a run of 4, and it's negatively sloped. Notice it's decreasing as I move from left to right. So I have a -3/4. Sliding into place, that tells me if m is -3/4 and b is -5, that y is equal to -3/4 x minus 5. Same idea for the one on the right. Again here, I want to find some points on my graph. Notice I've got a nice point right here, my x-intercept. So this coordinate would happen to be 3, 0. I've got another nice point right over here. I can use that to my advantage. So I've got 1, 2, 3, 4 down and 1 over here to the left. So that tells me here I've got a positive slope. I'm going up from left to right. My rise is 4. My run is 1. So I know that my slope m is equal to positive 4 over 1, which I'm just going to leave as positive 4. From here, maybe if I want to find something with a slope and a point, maybe I can use my point-slope formula. Say it with me. Point-slope form is y minus y1 equals m times parentheses x minus x1. So notice I've got a coordinate here. I'll call this my x1 comma y1. My slope m is equal to 4. All I need to do is substitute in. So I know that y minus 0 is equal to 4 times parentheses x minus 3. 4, or y minus 0 is, of course, just y. And then if I take my 4, distribute it to each of my terms, I would get that y is equal to 4x minus 12. Very nice. Moving on. Let's say I don't have some graphs. Maybe I want to work a little bit more abstractly. So for example, I want to find the equation of the line that has a slope of negative 5 over 2 and passes through the point 8 comma negative 9. So once again, my slope formula here might be my most effective strategy. So I'm going to use my y minus y1 is equal to m times parentheses x minus x1. Did I say slope formula? I meant point slope form. Whatever. It's late. My brain doesn't work. Not to say that it ever works to begin with, but it's working even less now. So from here, I know that my slope is m, so my m value is going to be negative 5 over 2. And then my point here, 8 and negative 9, I'll call x1 and y1 respectively. All I've got to do now is slot everything into place. So I've got y minus negative 9 is equal to negative 5 over 2 for m times parentheses x minus 8. Y minus negative 9 I can more simply write as y plus 9. And then that negative 5 over 2 I can distribute. So I've got negative 5 halves x. That's just negative 5 halves x. And then I want to do negative 5 halves times negative 8. For the sake of convenience, I'll rewrite that 8 as 8 over 1. Notice here, 2 and 8 both have a common factor of 2, so I can divide both of these by 2. Negative 5 over 1 times negative 4 over 1 is positive 20. So I've got negative 5 halves x plus 20. Subtract 9 from both sides. And when I do that, I'm left with y is equal to negative 5 over 2 x plus 11. Cool. Moving on. How about this guy? I have an equation of a line with a slope of 0 and a point of 10 comma negative 1. Well, notice here my slope of 0, that's going to be m. And I can again think about my point here, 10 comma negative 1, for the sake of variety. Remember, we've also seen that while we can use point slope, y minus y1 equals m parentheses x minus x1, let's also get some practice just using y equals mx plus b. So I know that y isolated is equal to slope times x plus the y-intercept. An effective strategy that we also saw is instead of thinking of 10 comma negative 1 as x1 comma y1, we can also substitute right into our x and y values in our slope-intercept form. So y equals mx plus b. If I take y and replace it with negative 1, equals my slope of 0 times x, which is 10, plus b. Here, notice 0 times 10 is 0, so I have negative 1 is equal to b. Knowing that negative 1 is equal to b and slope m is equal to 0, I can now just slot things into place in my y equals mx plus b. I know that y is equal to 0x plus b, which is negative 1. Of course, 0 times x is 0, so y equals negative 1 is the equation of my line. By the way, what type of line is this? Y equals, y is by itself. This guy is, bum, 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 horizontal. Very nice. Cool. I want to find the equation of a line with x-intercept of 9 and y-intercept of negative 21. So again, remember, our intercepts are points hiding in disguise. If the x-intercept is 9, to find the x-intercept, of course, that means that y is equal to 0. So that tells me here that the point 9 comma 0 is on my graph. If I have the y-intercept, That tells me that x is equal to 0. I'm on the y-axis. So that means that the point 0, comma, negative 21 is on my graph. I've got 2 points. In order to build an equation, I always need to start by finding slope, which I can use my slope formula for. So I know that slope is y2 minus y1 over x2 minus x1. Slotting everything into place, maybe I'll call this guy on the right my x1, comma y1. I'll call this guy on the right my x2, comma y2. Did I say right twice? I don't know. Again, brain totally off at this point. y2 we've identified as negative 21. y1 we identified as 0. x2 we identified as 0. And then minus x1, which we identified as 9. Again, the order doesn't matter. If you had plugged in your point on the right as your x1, y1, and your other one as x2, y2, that's totally fine. Here we get negative 21 over negative 9. Notice a negative over a negative is going to be a positive. And then 21 and 9, both of these have a common factor of 3. Divide both of them by 3, we get positive 7/3. So my slope is 7/3. Notice my y-intercept is negative 21, so this is my value of b. Slotting everything into place, I now know that y is equal to mx plus b, which is 7/3 x minus 21. Cool. Next up, I have a line that passes through the points negative 2, comma 5 and 4, comma 8. Once again, always need to start by finding slope. Either I'm using y equals mx plus b, or my point slope form, y minus y1 equals m parentheses x minus x1. Both of those need slope to function. So I know that my slope is y2 minus y1 over x2 minus x1. For variety's sake, let's switch it up. Let's call this guy x1, y1. Let's call this 2, x guy, y guy. No, this guy x2, y2. Slotting into place, that tells me that 5 minus 8 over negative 2 minus 4 will give me my slope. 5 minus 8 is negative 3. Negative 2 minus 4 is negative 6. Negative 3 over 6 reduces to 1 over 2. So my slope is 1/2. Now again, I'm going to use my point slope form. So I'll say y minus y1 is equal to m parentheses x minus x1. Again, I can use either of these points that I like. I've labeled 4, comma 8 as my x1, y1, so I'll stick with that label. Why not? If it ain't broke, don't fix it, and it ain't broke yet. So I'll take y minus y1, which is 8, is equal to m, which we found is 1/2, times parentheses x minus x1, which is 4. Taking 1/2 and distributing, I know that y minus 8 is equal to 1/2 x. Half of negative 4 is negative 2. All I've got to do is add 8 to both sides. When I do that, we find that y is equal to 1/2 x plus 6. Very cool. Moving on. Penultimate. Fancy SAT word of the day. Second to last. I've got 12, comma negative 5 and negative 4, comma 15. Once again, same idea, right? I want to start by finding slope. We'll say m is equal to y2 minus y1 over x2 minus x1. Let's call this point on the left our x1, comma y1. Let's call this point on the right our x2, comma y2. Once again, our order, as we've seen, does not matter. So I'm going to take 15 minus negative 5, divide it by negative 4 minus 12. From here, 15 minus negative 5 is 15 plus 5 over negative 4 minus 12. Well, that is negative 16. 15 plus 5, that's 20. 20 over negative 16. Both of these have a common factor of 4. So this would become negative 5 over 4. So my slope is negative 5/4. And now again, for variety's sake, instead of using point slope, let's get practice using y equals mx plus b. Remember, both of these are interchangeable, whichever you prefer, whichever feels like the path of least resistance to you, be my guest. So from here, I can take either of my points. Let's say that I choose the one on the left. Doesn't really matter. So I'm going to say my y value here is -5, which is equal to m, which we found is -5/4. X here is going to be 12. That's the x value of our coordinate here. And then all I've got to do is solve for b. So I've got -5 is equal to -5/4 times 12, right? Off to the side we can do this. -5/4 times 12/1. So I've got common factors here, 4 and 12. This reduces to 3 and 1. So -5 times 3 is -15. So this is -15 plus b. All I've got to do is add 15 to both sides to isolate b. That tells me here that 10 is equal to b. So m is -5/4. b is 10. Slotting everything back into y equals mx plus b, we know that y is equal to -5/4 x plus 10. Beautiful. And for our last problem together, right, the way that I word these things can be kind of creative. So here's a slightly creative version of a type of problem that we've encountered. I have a line that passes through -4, -5. It has the same y-intercept as x plus 3y equals -9, and I want to find its equation. So what I should probably do is find the y-intercept of x plus 3y equals -9. So let's take this friend right here. I know x plus 3y is equal to -9. My goal is right now to find its y-intercept. So to find the y-intercept, couple ways that we can do this. The easiest way, I think, to find the y-intercept is to plug in 0 for x. So the y-intercept happens when x equals 0. So here, I'm going to take 0, I'm going to substitute in for x, and solve for y. So this 0 I can ignore. I know 3y is equal to -9. We'll divide both sides by 3. When we do that, we find that y equals -3. So here, -3 is our y-intercept. Now that I've got that y-intercept, I want to find the equation of my line. Well, I know that if I have a y-intercept of -3, that means that the point 0, -3 is on my graph. And now I also know another point up here of -4, -5. Using those 2 points, I can now find the slope of my line. So I'm going to start by finding my slope, y2 minus y1 over x2 minus x1. From here, I know that I can take my 2 points, doesn't matter which one is which. Let's say that this guy here is x1, y1. Let's say that our y-intercept here is x2, y2. Slotting into place, I know that y2, -3, minus y1, -5, over x2, 0, minus x1, -4, will give me my slope. -3 minus -5, well, that's -3 plus 5. 0 minus -4, well, that's 0 plus 4. -3 plus 5 is 2. 0 plus 4 is 4. That means slope is 1/2. So I know that my slope is 1/2. I know that my y-intercept is -3. Slotting both of those pieces of information into place, I know that y is equal to mx, so 1/2 x, plus b, so -3. Very nice. Congratulations, you are now a master of finding equations of lines. Starting next time, we're going to see how we can further increase the creativity of the problems that we solve by talking about some parallel lines. But until then, have fun, be good. I'll see you when I see you. Deuces.